Hi children, welcome to Eclit Learning. So this is the fourth chapter for grade 9, use of microcontrollers. So if you haven't watched my previous videos for grade 9, please go and visit them because I have done videos for each of these chapters in the grade 9. So in this chapter, for the fourth one, I'm planning to do two videos. The first part will be mostly covering the theories, and there will be another part which will be covering basically how to code with make code for the microcontrollers, right? So this is the first part of chapter 4 of the grade 9 syllabus. So this is basically talking about microcontrollers, right? So in this scenario, these kids were talking something. You also may have noticed this. Sometimes when we are traveling, we can see even the sun is up. Even sometimes it's like 9 o'clock or 10 o'clock. Still, the street lights are on, right? So this is a great kind of a wastage of electricity. So that is what these two kids are talking. So this boy is suggesting, yeah, we can avoid this situation. Actually, if we use a light sensor and if we detect the sunlight and sunset, based on that, we can control the lights automatically, right? No need of a manual involvement, right? So that's a great solution for this problem. But the girl is telling about that she doesn't know that about light sensors and how they are actually controlled, right? So actually sensors, not only light sensors, there are so many sensors. You can measure things like, for example, maybe the temperature, maybe the water level of or the humidity of the environment, things like that. So environmental conditions can be measured using sensors, and based on the input given by the sensors, we can use different computer programs where we can take necessary actions accordingly. So basically, as I described earlier, sensors are used to detect environmental conditions, right? So if then it can be connected to a computer and can do actions accordingly. Now, in a computer, basically there are three functions happening, right? So it's about collecting data, processing, and then you output the necessary data, right? So microcontroller can be used for the same purpose, kind of. So you can process data which are sent by the sensors, and based on the given instructions, you can do the relevant output. For example, now morning or the based on the sunrise and the sunset, light sensor will detect it and will give the input to the microcontroller. So based on that, microcontroller will do the processing part, and based on that, you can either, if it's morning, you can switch off the light. If it's dark, you can switch on the light. So based on that, you can decide the output. So what happens is really the microcontroller processes all the data you get, and then based on that, it will be doing an action, right? So what is a microcontroller, right? A microcontroller is actually kind of a chip, right? It can do different kind of operations based on the given instructions. So in a microprocessor, we can see these four components basically. Uh, so microcontroller is something like this, if you haven't seen, right? So in that, we will have the central processing unit or the CPU as the computer itself. It is doing the basic processing part. And then we have the memory. Hope you have already heard these two terms, non-volatile and volatile memory, right? For example, non-volatile means like the ROM, where even though electricity is not there, the data in it will not be erased, right? So the program that the microcontroller should execute is in this memory, right? Non-volatile. It doesn't depend on the electricity. Volatile memory means like the RAM, right? Because when the electricity is not there, the data will be like erased. So it's kind of a temporary storage, right? So this is used to actually store the data like results and all when the microcontroller is at work. So it's a temporary thing, right? Uh, that is how this is happening, right? Like the CPU, right? When we work in the computer, so all this currently working information will be saved in the RAM, right? So similar to that, the microcontroller also working the similar manner. So then we have the system clock. So system clock is actually the electronic device which will be synchronizing all the components, very similar to the computer system clock. Then you have peripheral devices, right? So in a microcontroller, there are small pins. You can input data and output information, right? So this thing can be used for with the other peripheral devices like that. So what are the occasions we use sensors or the microcontrollers? One thing we talked about is something like the solar lamp, right? So in a solar lamp, solar cells, sensors, and microcontroller will be there. So when there's the light, the solar cells and microcontroller, these things will be help to light the lamp, right? So when it is dark, the lamps will be automatically switch on, right? When there is light, these lamps will be automatically switch off, and because it's having solar cells, it doesn't need any other power source, so it will be working based on the solar power existing conditions, right? And in the washing machine also we have these same concepts, right? The user can give the instructions, how many rinses, how many time you want to spin like that, so then it will automatically work, right? Then microwave oven also have the same structure kind of. So we can give the instruction how much temperature you need, how much time, like 1 minute, 2 minutes, like that. Then it will automatically work and will stop. We don't have to manually stop this, right? So here they have given some kind of important note kind of thing. So there's two concepts like single board computer and the single chip computer, right? So if you have heard about Raspberry Pi, this is kind of a single board computer which has all the circuit board with memory input and output and microcontrollers and all these things. It's kind of a mini computer like, okay? And when it comes to the single chip computer, like this central processing unit, input, output, memories are also built to a IC, right? So to an integrated circuit like the Arduino clip, right? You can read or watch more videos on these terms. I'm not spending so much time to explain all these things separately because in here it's mainly focusing about the overall concept. Okay, use of microcontrollers, right? So microcontrollers actually they have a kind of a base kit, right? You can buy. I saw this in Daras also. It's about 4,000 rupees or something like that. There is a kit kind of thing, or you can buy the unit separately also. So this can be used to obtain required outputs, right? These kind of kits like microbit kits and Arduino, Raspberry Pi, those like kind of a microcontroller kits itself you have. So you can use this for your experiment. This is very interesting chapter, right? Even though theory may be a bit boring, this has so much potential, right? For example, for this chapter only itself, you can spend around 1 month like work. You can do different experiments because this is very interesting chapter, right? Don't just follow the theories and stop it here. That's why I used to explain the coding part in another video as well. So you will know what are the things at least we can do from this, right? So you can try yourself because I cannot explain everything. This is just a like online video for like don't want to extend it more than 1 hour. So that's the purpose of this series. So but you can work on that more, right? So in this chapter, we are basically like talking about microbits and about Arduino microcontrollers. So they have explained some, right? So the microbits. So BBC Institute had developed this microcontroller, right? So you can do a lot of things. It actually has a module to get inputs, process them, and output them. It has a memory, right? Actually, this board is having like basic features of a computer kind of. And it also has sensors. That's the most important thing. Because if you think about Arduino UNO board, it is not having these sensors kind of thing, right? Then we have to buy separately for the sensors. But in this one, it actually has the relevant sensors also. So this is the front view of a microbit module, right? So if you think about the first two, right, A and B, there are two programmable buttons. So you can program this one. For when you click the A button, what will happen? When you click the B button, what will happen? Something like that, right? Then two means you have digital and analog input and output pins, right? Then the most kind of interesting thing here, you have individually programmable LED bulbs, right? So these bulbs you can like with kind of like XY coordinate. So you can like point out each of these LED bulb with a XY coordinate thing, right? And then you have the fourth one where it is the port to connect for the power. And then you have the ground back port. So then we'll go and check the rear view, right? So sixth place, here you have the Bluetooth smart antenna. So you can use this thing to connect to Bluetooth and transmit radio waves as well, right? And then seventh means the central processing unit, right? And eighth one, this is the micro USB port. Now, why this is important? Not sure whether you know. From you can code for this microprocessor and the online in the web browser, and then you can download that program, and then you can actually transfer that program to the microcontroller. So for that, we can use this micro USB port, because then you have to have the micro USB cable, and from that from the computer you can actually send the relevant code to the microprocessor. Then you have the battery connector. So you can connect this to a like external power source, because then you can work separately. Like don't need to connect always to the laptop or the computer. You can give a separate power source, right? And then here, this is the place where accelerometer and compass, right? Like the sensors kind of thing you can use. And then the 11 means these are the pin edge connector, right? Okay, so as I earlier told, this micro bit module you can connect to the computer using a micro cable, USB cable, right? So this is the same thing you use for mobile phones also sometimes for the charging and all. So in that kit I told, in that kit it will have all these things if you want to buy as a package, but it's a bit expensive as you're buying as a package kind of. So when you connect this microbit module to the computer, it will be shown like this. Very similar, like when you plug up a pen drive, it can be seen here, right? So similar to that, if you connect the microbit to this computer, you can see it like this. And you can go inside and do different things. So the coding part I will just skip, because I'm going to explain it later. The Arduino microprocessor, right? Because here they have just given you some explanation of this board as well. So it's a microprocessor developed by Atmel company, and it is having components like this, right? A bit similar to the same thing which we discussed earlier. So actually this is the microcontroller, right? Itself, and other than that you have the mini USB and power regulator, DC power, digital pins to cover this, right? And power pins, analog pins, right? But the main thing is the microcontroller. It's the most important thing. So they have explained the items also. What is the mini USB, right? So this is actually where you can connect to the computer as the microbit module. And then you have the electric controller, right? This is actually controlling the voltage needed for the circuit. And then DC power supply, right? Either you can connect the Arduino board to the computer, right? When it is connected to the computer, it will get the 5 volt required voltage from the computer. But if that's not the case, as the microbit module, we can connect this to an external power source as well, right? Then comes the power pins, right? So you can use this to provide electricity from the board to an external circuit, right? You can control other equipments from this one, right? Then comes the analog in pins. So analog pins are actually can be used to send analog inputs, right? Sensor readings can be done to the board, right? Because I hope you saw that here we didn't have any sensors inbuilt kind of. So from the other external sensors, we can get the values. So this is a microcontroller chip, right? And then we have the digital pins, right? So this is actually used to get the digital inputs and provide the digital outputs. Input and output both are there, right? So when it comes to Arduino, there are different kind of boards. So Arduino UNO is the most popular thing because it's cheap and easy to buy. This is the main thing. Other than that, we have Arduino Mega board, Nano board, Micro board, like that, different kind of boards. So basically Arduino Uno board is the one which is mostly popular thing, right? So these are the other peripherals you can connect to the microcontrollers. The breadboard, maybe you have heard of it. So breadboards can be used actually to make circuits, right? You don't have to do the welding to connect the circuit parts. You can easily use this, right? So you have positive edges and negative edges like that. So this is that board for plus and minus pins are there. And then we have LEDs. Very most probably you have heard LEDs or light emitting diodes. Actually, in here electricity travels only one direction. So when the electricity goes through, the light will emit. So that's the basic LED. So if you see the microbit module, the LEDs were there inbuilt, not like the Arduino board. Arduino board didn't have that. But in the microbit module, we had like 25 LEDs. So it's very easy to do the like kind of programming and check yourself, right? And comes the sensors, right? So as I earlier indicate, so sensors can detect and measure physical properties, right? So here they have given some examples of sensors, passive infrared sensors, right? Okay, so this can measure infrared objects, something like humans, right? So if you detect a human, it will give a different kind of output, something like that. So here you have the ground terminal, and this is a positive terminal, and this is the output terminal. Okay. So here we have two other trim ports as well, delay adjust and sensitivity adjust, right? So sensitivity adjust, actually what it is doing is it will be enabling to adjust the distance covered by the sensors. So up to 7 meters, this can do the detection. And then other one is actually delay adjust. It will adjust the time delay to release the output. Okay. Then comes the ultrasonic sensors, right? This is actually using to like estimate the distance from that particular sensor to the object, right? It's actually done using the ultrasound signals. First, it sends the ultrasound signals to the object, and then uh, like interpret the reflected signals, similar to the bats, how the bats are communicating, right? So bats are also doing the similar thing. They send the ultrasonic waves and then find the route, right? Whether there are any obstacles or not based on the echo. So same approach is used in this sense as well. So here also there are some VCC pins, the negative terminals, right? To get the echo and to the input and all like that, there are different kind of uh, pins for this sensor. So that's the end of the chapter, but please remember that there will be another video for the coding part, but I will summarize this one. So in a microcontroller, there are basically four components. You have the CPU, memory, system clock, and the peripherals. So we can see microcontrollers in different uh, devices like the microwave ovens, washing machines, even traffic lights, computer printers, solar lamps, remote controllers, right? So most of these smart devices will have microcontrollers in it. Then there are different microcontroller based kits like microbit, Arduino, Raspberry Pi. So you can go and research on these things separately, right? Because these are like separate areas you can study if you're interested. And we can actually code for these controllers. Like there are different kind of tools and languages you can use for. In here, actually, we are basically using the microbit for that make code block. We can easily do the programming by using that. So thank you very much for being with me. So if you haven't still subscribed my channel, please do subscribe and click the bell notification also. So put any comments and like this video so I can answer your questions if you want. So thank you very much. Please remember to watch the next part as well for this.